Hey all, welcome to ShareTrek. This is Raj here. Friends, this is my way of saying thanks to all the members who have been supporting this channel all these many months when I was not even putting out a video. So I'm going to start this regularly. I think that we have to encourage people to become members so that this channel becomes viable and I can keep doing this work which you seem to appreciate and you have put your support behind. That said, I'm going to talk today about Lenacapavir and how exactly it works. I'm going to walk you through this National Library of Medicine's NIH article which describes it in detail. I'm going to break down the details of some technical terms that are used out here. So this is going to be a special members only treat. The other people in the channel are not going to be able to see it. You are seeing it because you are members. Thanks a lot for staying engaged. That said, let's see what we have here. I've scrolled down directly to where it says pharmacodynamics of Lenacapavir, the mechanisms of action. So we have a whole lot of text out here which the common layman generally finds difficult to understand. It has got some measurement terms and it has got things like CA subunits, GAG/GAG pole functioning, and it also has other information like this entire paragraph which is full of things like PBMC, CD4 plus T cell lymphocytes. Of course, we know CD4 lymphocytes, but PBMC, and then there's a lot of other measurements and NTRIs, etc., etc. So I'm going to demystify these. This entire section, the mechanism of action, and I'm going to explain it to you. So to start with, I'm going to clarify some of the concepts that we have out here. The first one is GAG/GAG pole functioning, where I would say that if you look at the description out here, it talks about GAG pole functioning and reducing production of CA subunits. So GAG and GAG pole are two important viral proteins that play a key role in the formation and maturation of new virus particles. So we had talked about GAG being like a trimer. GAG helps form the viral particle structure, while GAG pole is a fusion of the GAG protein with other proteins required for replication and assembly, including the reverse transcriptase and integrase enzymes. So Lenacapavir interferes with how these proteins work together, disrupting virus assembly and preventing the virus from maturing properly. CA subunits are capsid subunits. CA stands for capsid, which is a protein shell that surrounds and protects the genetic material of the virus, the viral RNA which is inside. It is made up of individual protein units called subunits, and these subunits come together to form a hexagonal structure which is also called as hexamers, and pentagonal structures which is called as pentamers to create the full viral capsid. Lenacapavir works by affecting the interaction intra and hexamer interactions and disrupts the proper formation of the shell. A hexamer is a group of 6 capsid protein units that form a part of the viral shell. The interaction between these subunits are critical for the stability and the shape of the capsid. And while extra hexamer interaction refer to how hexamers interact with others to form the entire capsid structure, Lenacapavir increases these interaction, but in an irregular way, which leads to the assembly of defective, non-functional capsid that cannot properly protect the viral genetic material. So basically, it would end up leaving gaping holes in the capsid so that the body's immune system has access to the viral RNA before it enters the CD4 cells, and therefore the viral RNA can be destroyed or dissolved and rendered unusable or unviable. So this is how Lenacapavir works. So now that you understand these main concepts, I'd like to just simplify how Lenacapavir works. Lenacapavir is a groundbreaking HIV treatment because it works in a completely new way compared to traditional antivirals. Unlike drugs that target the virus's enzymes, Lenacapavir focuses on the capsid protein, a key structural element of the virus. The capsid acts as a protective shell around the virus's genetic material. It's made up of proteins that form structures called hexamers and pentamers, and these subunits interact with each other to maintain the capsid's shape and function. Lenacapavir's action starts by preventing the virus's genetic materials, that is cDNA, from entering the host cell's nucleus. This is important because it stops the virus from integrating with the genetic code into the host cell's DNA, which is the first critical step in a virus life cycle. By binding to the capsid protein, lenacapavir blocks the virus's ability to assemble new virus particles and prevents them from being released into the infected cells. Additionally, lenacapavir increases the strength of interactions between the capsid subunits, which sounds good, but the result is actually harmful to the virus because there are these dummy units that get in there and they mimic the actual protein that is needed by the virus to assemble the capsid, and then this results in the inhibitions of actions such as reverse transcriptase inhibitors, protease inhibitors, and integrase inhibitors. This shows that lenacapavir works in a completely different way and remains effective even in the face of viral mutation. One of the key advantages of lenacapavir is its high potency. It was shown to be effective even in cell lines that were resistant to other classes of HIV drugs, such as reverse transcriptase inhibitors, protease inhibitors, and integrase inhibitors. This shows that lenacapavir works in a completely different way and remains effective even in the face of viral mutations that may make the virus resistant to other treatments. This also includes the GAG polymorphisms, natural variations in the GAG protein that might make the virus harder to treat with other drugs which target the GAG protein. But lenacapavir remains effective despite these changes because it's working on the shell, and the delayed release action makes it twice in a year kind of a drug, which is even more effective. And it can work as a PrEP, but it could also work as ART to prevent the creation of new reservoirs and keep the virus at bay, acting in concert with other ART. In summary, I think lenacapavir is one of the most potent HIV drugs available, offering a unique mechanism of action that disrupts multiple stages of the virus's life cycle, making it a promising option for people living with HIV, especially those who have developed resistance to further treatments. So treatment-resistant patients could find a lot of help in arresting the progress of the disease, arresting the creation of new reservoirs. So this is what I think is very important to know about lenacapavir. And for HIV to become resistant to lenacapavir, it has to come up with a new capsid design which can circumvent lenacapavir's action. And that to me seems to be a long shot. So at this point of time, I think for 2025, the best news is lenacapavir long-acting dosage is even, I would say, a bonus on top of lenacapavir itself. So that, my friends, is a summary of explanation of how lenacapavir works, and I've taken it from the NIH website. All of you can go to the NIH website and look at this yourself and do your own analysis and get an even better understanding. If you have any questions, please put it in the comment section. And members, thanks once again for being members with the channel. And this video is only available to members. So with that, my friends, I'd like to end this video here, and I'll catch up with you again in the next video. Bye for now.